Hello again. Today we're going to talk about identifying polynomial functions, okay? A polynomial function would be written like this. F of x equals 6x squared plus 7x minus 2. You'll notice that all the exponents, like 2, and the exponent here would be 1. Even this one has an exponent, but it's 0. All of the exponents are integers. As a matter of fact, they're all positive integers. So if you have a function and you want to know, is it a polynomial function? If all the exponents are positive integers, then it is. But this can be a little tricky. Some things to look out for. So remember that these are not parts of a polynomial function. If you have a fraction and x is on the bottom of the fraction, anywhere in your function, it is not a polynomial function. If you have a radical and x is on the inside of that radical, it is not a polynomial function. Or if you have a number like 4 raised to the x power, it is not a polynomial function. These are not parts of a polynomial function. All right, let's look at some examples. If I have f of x equals 7x minus 2x squared minus 8. The question is this a polynomial function? Well, I'm going to say yes, because that's x to the first power, that's x to the second power, and this is x to the 0 power. So I would say yes, this is a polynomial function. Now I'm going to ask, let's write this in standard form. Can you write it in standard form? Well, I'll do f of x equals, all right, our highest exponent is the 2, so it's f of x equals negative 2x squared. I used that, plus 7x minus 8. Next, I want to know, what is the degree of this function? The degree of this function is the highest exponent, and the highest exponent is 2. Next, I want to know the type. If you'll remember your chart that we went over, you'll see that the type, when the degree is 2, is a quadratic. And they also want to know, what is the leading coefficient? Well, the leading coefficient is whatever is out in front of your first x, and that's negative 2. And that's how you identify polynomial functions. All right, let's see here. Is this a polynomial function? Well, I see here I have x to the second power. Here I have x to the 5th power. But right here, I have a negative square root of x. And the square root of x is actually equal to x to the 1/2 power. So this one is not a function, because we look over here on our chart and it shows that if I have x inside of a radical, that it is not a polynomial function. So I would say no, this is not a polynomial function. Now, what about this one? Is this one a polynomial function? Well, notice that I have an x squared, but it is on the top. Well, that could be written as 1/3 times x squared. So if I continue rewriting it, now I have it in standard form. Well, I have x to the second power, x to the first power, and x to the 0 power. So I would say, yes, this is a polynomial function because it doesn't break any of the rules. The x is not on the bottom of a fraction. The x is not in a radical, and the x is not an exponent itself. So I can say that this is, yes, this is a polynomial function. All right, and now I've written it in standard form. All right, and now I want to know the degree, the type, and the leading coefficient. Well, the degree is the highest exponent, which is 2. The type, well, that would make this a quadratic. And the leading coefficient is the number in front of the first x, which is 1/3. All right, what if I have f of x equals 6 to the x power plus 3x to the 4th minus 11? Well, let's look at our chart over here, and let's see if we have anything that looks like anything over here. It looks like there's nothing with x on the bottom of a fraction. X is not in a radical, but I do have x as an exponent. When x is an exponent, this is not a polynomial function. So we would say, no, this is not a polynomial function.